All right. Thanks everyone for the opportunity to be here. I'm an engineer, so I'm a consumer of HPC, and we heard some kind of alarming statistics yesterday from Earl, actually, about how science and engineers actually less than 1% of them have access to HPC resources to run modeling and simulation. That's kind of a crazy figure, and that's one of the things that we want to fix at OnScale. So we think that we're the future of engineering. We're going to be commoditizing HPC access for every scientist and engineer. And if you take a look at any engineering firm, you see this problem. You see computer-aided engineering workloads and legacy CAE that is too costly, too risky, too slow. And we all know that engineering workloads fluctuate throughout the year. Sometimes you need lots of CAE if you're going to launch a new product. Sometimes you don't. So the workloads are variable, but the supply of CAE from a software and a hardware perspective is fixed. And what that does is, in areas of where your demand exceeds your supply, you've got a bunch of engineers that are waiting around for their computers to solve numerical simulations and give them engineering data. So you're increasing product design risk, you're wasting time. In areas where your demand is less than your supply, you're just wasting money. You've got hardware and software that's sitting around that's very expensive, in some cases $100,000 or more for one of these software licenses, and maybe $100,000 for an HPC, and it's just sitting there unutilized. So the basic takeaway here is that legacy CAE does not scale. The solution to that problem is on-demand, scalable cloud CAE, and that's exactly what we've built at OnScale. So at OnScale, we have free software licenses, so there is no licensing. You can download our thin client. It's a full multi-physics package that is comparable to COMSOL or ANSYS. You can set up models here. You can set up boundary conditions, material properties, all that kind of stuff. And then when you're sending up a problem, we intelligently create just enough hardware to solve that problem. So let's say you're doing a massive parametric sweep or an optimization study. We can actually break up your model, send it over 1,000 HPCs on the AWS cloud, and give you results back 1,000 times faster than you would have if you'd done that serially on your local workstation. The target markets that we're going after these are markets that are underserved by CAE providers and HPC providers today. There are areas like MEMS devices, IoT sensors, driverless cars, 5G RF filters. Now that I know how a quantum computer works, I'm gonna get started on making a quantum computer, like a probabilistic wave algorithm. Robbie, my co-founder, can do that. Yeah. Thank you. So anyway, I'll give you a minute back of your time. Come say hi to us. Tell us what your problems are, and let's talk about how we can solve that with the future of engineering.